All right, ladies, gentlemen, let's learn a few descriptive statistics that we need to learn to make sense of the statistics that we get in classroom in the form of results of tests. Okay, let's start with the very common ones. The measures of central tendency. Of course, you've heard of the mean, median, and the mode. These are the commonest statistical tools used in test and measurement. So the measures of central tendency are descriptive statistics that measure the central location or value of sets of scores. Central location, where do most of the scores concentrate? Okay, they are widely used to summarize and simplify large quantities of data. Okay, you have, let's say, 100 assorted scores. How are you going to make sense out of 100 different scores? Of course, we need to organize these scores in some ways so we can see patterns and interpret these patterns that emerge from processing the scores that we get. You know? And one way to do that is to look at the concentration of the scores. Where do they concentrate? Where do they cluster? So we have the mean, median, and mode for this purpose. The mean, as you know, is what everyone knows, the arithmetical average of a set of scores. It is obtained by, of course, adding all the scores in a distribution. Look at the formula. Summation of all x's over n, the n being the number of scores. The x bar there is the symbol for the mean. So x bar, meaning the mean, is equal to summation of all x's or all cases or all scores divided by the total number of scores. Okay? It's as simple as that. But it tells you many things, as you will learn later. By the way, we use that formula if the number of scores is equal to or fewer than 30. When the number of scores is greater than that, then we need to cluster the scores into range of scores with a definite interval, as I will explain to you later. Well, you know how to calculate the mean. For the example given there, 17 plus 14 plus 14 plus 13 plus 10 plus 8 plus 7, etc. Kunwari, we get a total of 90 and our n is equal to 8. Therefore, we divide 90 by 8 and we get 11.25, which is the mean. Simple as that. We use the mean for getting our average or general average. You have done that since you're elementary. Okay, let's go to the median. The median is the score in a distribution below which half the scores fall. In other words, half the scores are above the median and half are below the median, which is why the median is also known as, please take note, it's the 50th percentile. So P sub 50. P sub 50. The median is also equivalent to the second quartile. So the median is equal to the 50th percentile and equal to the second quartile. What does it do? It splits the distribution into upper and lower 50%. That value, which is not necessarily a score, splits the distribution into 50% below and above it. No. Half of the scores fall below, half of the scores fall above it. To calculate the median, the scores are rank ordered. So organize the scores from highest to the lowest, then one simply counts from one end, from the top. Ilan ba? Ilan ba ang scores altogether? Tingnan natin ito, ha? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 scores. Okay? So count 5 from the top. Count 5 from below. That remains, you have an 18 there in the middle. That 18 there is the median. So that above 18, you have 50% of the scores. No? Below 18, you have 50% of the scores. Now, this is the case when the set of scores or the data set is an odd number. There is an odd number of the scores. In this case, you have 11. It's an odd. So we get just the middle score and indicate that as our mean. What if the set of scores is even? Let's look at this. No? There are two middle scores. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are two middle scores there, 8 and 7. What do? We add these two, that's 15, and divide by 2, which gives us 7.5. So the median in this example is 7.5. Get it? Pag add, get the middlemost score, that's the median. But firstly, we need to arrange it from highest to lowest. If it's even, then we get the two middlemost score, add them together, and then divide by 2 to get the median. That's easy enough. Okay. The median is relatively easy to find in studies with small number of subjects. What is small? Statistically, 30 or below is small. Beyond that, that's big enough already. So the number of scores increases. The calculation is done either by a formula or by placing the scores into intervals of scores like what you will see later, and using the interval to make the calculations. The computer is able to apply these more complicated calculations easily, quickly, and reliably. So in other words, use any statistical program. You can even use simply the Excel to do this, including computation for the mean, computation for standard deviation. You can do that, but what is very important in our discussion today is you understand what it means. Because in the lab, you will not be asked to compute, but you will be asked to interpret. So be sure that you understand the concepts. Mean, median, and mode as the measures of central tendency. Okay, let's go to the mode. The mode is simply the most frequently occurring score in a distribution, and it is found by counting the number of times its score was received or its score occurred. Like in the example given below, how many times which score appeared more than once. 18 and 22. 22 appeared more than, 18. 22, how many cases are there? 3. 18, 2 cases. So this set of data has 22 for its mode. Let's repeat. The mode is determined by simply looking at how many times does a certain data appear, and the most number of times the data appears is determinedly the mode, as in the example given. 22 is the mode of the distribution. Let's go to the measures of variability. Variability. How varied is the distribution of the scores? Another word for that is how scattered are the data. Scattered around what? Around either the median or the mode. Scattered around or deviating from a central measure. It could be, the variability could be deviating from the mean or deviating from the median. If the set of data, we try to determine the set of data deviating from the mean, then the measure of variability that we are going to look for is the standard deviation. If we are looking for deviation from the median, then the standard deviation, then the deviation we are looking for is what we call the quartile deviation. Ulit po, deviation from a central point. If the central point we are considering is the mean, then we are looking for standard deviation. If it is deviation from the median, then we are looking for deviation from the median quartile deviation. Okay. The roughest measure of variability is the range. Range. What is it? It's simply the difference between the highest score and the lowest score. The highest is 95, the lowest is 40. The difference is 55. 55 is the range. But remember, the range only considers 2 points in the data set, the highest and the lowest. It doesn't tell you how the other scores between these two deviate from each other. That's why we need to look for either standard deviation or quartile deviation. Okay. Measures of variability are used to show the differences among the scores in a distribution. We use the term variability or dispersion because the statistics provide an indication of how different or dispersed the scores are from one another. Okay, we will discuss the 3 measures of variability: range, variance, and standard deviation. As I've said earlier, the range is the simplest but also the least useful measure of variability. The range is defined as the distance between the smallest and the largest scores and is calculated by simply subtracting the bottom or the lowest score from the top or the highest score. For the following scores, then the range is, as you can see, 26 less 6 is 20. The range is a crude measure of variability and is unstable because the range can be biased. It is rarely used as the only measure of variability. We report the range, but um, the range is, range is like this. But the more accurate measure of dispersion will be the standard deviation. So although we report the range, we also have to subsequently report either the quartile or the standard deviation. Variance. What do we mean by variance? The variance, or statistically represented by those symbols, is a measure of dispersion that indicates the degree to which scores cluster around the mean. The variance provides the researcher with one number to indicate, in a sense, the average dispersion of scores from the mean. Computationally, the variance is the sum of the square deviation scores about the mean divided by the total number of scores, as you can see in the formula. It's so easy to determine. I'll illustrate that later, on the board. First, any distribution of scores, the variance can be determined by the following steps. You calculate the mean, calculate the deviation scores from the mean, square its deviation, sum all the deviation scores, and divide the sum by. All right? You can just follow this later, because I'd like to discuss how we find the mean, median, and mode, and the standard deviation when we have huge number. Okay? Another formula that can be used to calculate the variance, which is computationally more simple, is like what you see on the board. Variance is equal to summation of all x's raised to the second power minus n times the mean raised to the second power divided by n. Okay? Standard deviation is defined by the formula summation of the quantity x minus the mean squared divided by n, and then you get the square root. I will illustrate that later. Okay? To calculate the standard deviation, we simply add one step to the formula for variance, that is taking the square root. The standard deviation is commonly reported in research, and with the mean is the most important statistic in research. It tells the number of scores. In other words, that is the percentage of scores that are within given units of the standard deviation. Is explained in the section called normal distribution, which follows. Now, at this point, I'd like to illustrate the measures of central tendency. What do they mean? And the measures of variability when we have n greater than 30. In other words, we need to study when we group scores into clusters or ranges, because they're too unwieldy to take singly. All right. I'll illustrate all this on the board. No? I have a data set of more than 30 here. The n is 50. And so, what we need to do, I'm trying to illustrate here how we are going to find the mean using what we call the group data. Okay, and we call this finding the mean through the short method. Earlier, we found the mean, median, and mode through what we call the long method. Now, this one is the short method. What you see here is the clustering of scores. No? What's the interval between 50 and 54? What's the interval? Oh, let's count. Gamitin na lang natin ang fingers natin, ano? 50, 51, 52, 53, 54. What's the interval? The interval is 5. So, we group the scores using the interval of 5. In between this is 5. In between this is 5. Okay. After building what we call the step interval, steps interval, then we tally off the scores. Each of the score is tallied. Afterwards, we turn them into frequencies. All right, so that the score 90, between 90 to 94, we have one occurring score. Between 85 to 89, there are three scores. Between 60 to 64, there is 10. Between 65 to 69, there is 15. What then is the modal range? In other words, which is the range of scores that has the greatest number of occurrence of the scores? It's 15. Okay, so the modal range is 65 to 69. If we want to be very precise about it, then we just get the midpoint of these two values. What's the midpoint of these two values? 65 plus 69 divided by 2, that gives us 67. All right, so that's what we call the midpoint. I'd like you please to remember these words that I use, midpoint, okay? Now, this n represents the total number of cases or total number of scores. Now, we would like to find the mean using this. Maybe some of you had learned this in your lower years in college, but for others, maybe you need to refresh your memory. All right, to do that, we need to build our deviation. Deviation from what? Deviation from the mean. Deviation from the range of scores where we assume the mean to be. All right, you can assume the mean to be anywhere here. You can assume your mean anywhere in anywhere of these steps. But usually, people would get the one with the greatest number of frequency. In this case, it's 15. So, let us assume the mean to be here. Pwede dyan, pwede dito, pwede doon, pwede anywhere. Pwede nga dito. You don't want to work with negative numbers? Then choose this. Then you will not have to work for negative numbers. Okay. Now, let's assume the mean to be here. So, let's mark this off. This is where I assume my mean to be. We are going to mark that off. Okay. All right. And mark that off as our point of origin. And we build our steps, deviation from our assumed mean. This is one step away from the mean. Another step going up, up, and up. So this is 5 deviations away, 5 steps deviating from the point of origin, which we choose to be our assumed mean. This one is 1 step going down. That's why negative yan. And there. But actually, we don't need this except for determining deviations of the steps. What we actually need is the FD. What's the FD? As the term suggests, is frequency deviation. So we have to multiply them. 5. Go along with me. 12. 12. 8. 1. 0, of course. 10. Negative 10. Negative 10. Negative 3. All right. We need this to get summation FD. This is the value that we need to find because we will be using the formula assumed mean plus summation FD, that's it, divided by n times the interval, which is 5. Okay, we assume the mean to be in here. So we need to get the midpoint. The midpoint being how much? 67. Right?
Pagkatapos mo, di mo pagbukaon, picturean ko.
Opo. Okay. All right. Now, how do we get the summation FD? You know how to add algebraically, don't you? So we get the sum of all this, and we get the sum of all this. So 5 and 12 is 17, plus 20, 37 plus 1 is 38. Check it. 5, 9, 10, 18, carry 1, 38. And this one is 23, negative. So what do we do when we have negative and positive added together? We get the difference, algebraic difference. So what's the difference? 5, 15. Negative or positive? Positive, of course. We attach the sign of the one with the greater value. Less 23 equals 15. So summation FD is 15. What is our N? 50. What is our I? 5. Okay, so computing this now, we have 15 divided by 50 is, okay, 15, oh sorry, yes, 15 divided by 50 equals 0.3 times 5 equals 67 plus 0.3 times 5 is 1.5. Okay, add them up together. Then we have 68.5. Okay, let's review the process, mga dearest. What's the mean of this set of data? 68.5. Oh, it falls there, no? Doon sa pinili nating assumed mean, nandoon siya. 68.5. Okay, that's the mean. I hope you were following me. Mean is denoted by X bar. Let's put that there. 68.5. Okay. What do we need? The column for the frequencies, which is already set. We need the column for the deviation, which we need to build. And deviation from what? From where we assume the mean to be. And we have to multiply the F and the D to get the FD, which we need to sum up, so that we can apply the formula. So assume mean, which we need to determine arbitrarily, no? Add that to the summation of FD divided by the total number of cases and multiply that with what? With the interval. And we get this. So it's really very easy to do or to find the mean using the short method. Okay, let's go to the median. Okay, for the median, we don't need this. But I would like you to take note of the process because it's different. Huh? Siyempre, different. Okay. Let's erase this. For the median, ladies, gentlemen, we need only the column cumulative frequency. But before we move on, I'd like you to understand the concept of what we call the lower limit. Lower limit of what? We need also to understand half the score. half the score. Okay? You know what the n is? Because we need this in our formula. No? And we need, of course, to understand cumulative frequency. And, you know, lower limit, half the score. All right, half the score. This is the very first value that we need to determine. Half the score is, of course, half of the end. What is half of the end? It's 25. Once we have determined that, then we need to find the LL. What is the LL? The lower limit. In fact, what we are after is the real lower limit. What do we mean by real lower limit? If the lower limit is 70, what in fact is the real lower limit of the integer 70? It's, can you remember another, how do you call this, the rounding of numbers, you know? The lower limit of 70 is 69.5. The upper limit of 70 is 70.5. So actually the integer 70 extends from 69.5 to 70.5. So the real lower limit of any one of these are the lower limits, is zero point 0.5 less than the lower limit that appears there. So this is the apparent lower limit, but we are after the real lower limit, which in case of integers, it's 0.5 less than the apparent lower limit. Okay. Now, having said that, we will have to build our cumulative frequency. Let's do that. 1 plus 5 is 6, plus 10 is 16, plus 15 is 31, plus 7 is 38, 42, 46, 49, 50. So if we are accurate in getting the cumulative frequency, that last number there should equal our n. All right. Now let's look for that value that should not exceed 25. What is 25? It's half the score, half the n, so to speak. What's half the n? 50 divided by 2. Okay. Now, what is the value there that should not exceed 25? If we choose this 31, it already exceeds 25. So it's not that, but this one. It could equal to, but not more than. Okay? So 25. Ito ngayon ang tinatawag natin na cumulative frequency. Okay. It should not exceed half the score. Why? Because we are going to use the formula lower limit plus half the score, or half the n, if you like, half the n minus cumulative frequency divided by interval, and then times the interval. Oh, frequency of the median. Okay, let's now, we know the n solve to this one, we know this to be 25. We know our cumulative frequency to be 16. The difference of that we have to find. Now, we know for a fact, the I is enough. We know for a fact that the median or half of the score is not here, but in the next step. Not here, not here where we choose the cumulative frequency, but in the next step. We know for a fact that the median is there. So, hahanapin natin yan. Gagalugarin natin kung nasaan yan. Pero nandyan yan. Ang sagot ay hindi, ay within this. Within this value. Kaya hahanapin natin. So, ang kailangan natin is the lower limit. Ang lower limit is this one. Okay? Ang sabi natin, ang lower limit ng integer na yan is 64.5. O, ano na lang ang hahanapin natin? Ang hahanapin natin ay ang frequency of the median, which is that one. So, kung ang median ay nandyan, ang frequency ng median is definitely ito. Alright. So, we have completed our substitution. Let's now compute for that. 25 less 16 equals 9. Divided by 15 times 5 equals 64.5 plus 9 divided by 15 equals 6.6 times 5, 0.6 times 5 equals 3. Ulit. 9 divided by 15 equals 0.6. Multiply that by 5 equals 3. That's it. Therefore, our median is 67.5. Alright. It isn't very far from the mean. Let's put that there. Median is denoted by this symbol. It's 67.5. Okay. We can find the mode which is defined by the derived formula. What? Okay. Sige. So the mode, if we know the median, we know the mode. We know the median, we know the mean, then we can get the mode. The mode is defined by the formula 3 median minus 2 mean. So 3, which is a constant, times 67.5 minus 2 times 68.5 equals. Mode, by the way, is symbolized by that. Okay. Let's get the value. 3 times 67.5 equals 202.5 less 2 times 68.5 equals 137. Okay. Will give us 202 minus 202.5 minus 137 equals 65.5. The mode is equal to 65.5. Okay. Mga dearest, take note. Take very good note of what I'm going to say. If the value of the mean is equal to the value of the median is equal to the value of the mode, kung pare-pareho sila, then you have what we call a normally distributed set of scores. Meron kang tinatawag natin na normal distribution. Normally distributed set of scores. Okay. And if you are going to plot the scores or make a frequency polygon for that scores, you will have a normal distribution, so to speak. A normal curve. Okay. We can only have this kind of frequency polygon. What do we call this? Frequency polygon. We can only have this frequency polygon if our mean is equal to the median is equal to the mode. If they are different, especially if the values are so disparate, then we have what we call skewed distribution. Palagi po itong lumalabas. Several times na itong sinabi ng mga estudyante na kumuha ng LET, lumabas ang konsepto na tinatawag na skewed distribution. So let's try to understand kung ano ang ibig sabihin ng skewed distribution. Okay. If we are going to illustrate this frequencies na ito, ano ang lalabas? Isa, tatlo, apat, pito, 50, 10, 5, yan ang illustration. It's not normal, is it? But skewed. Skewed to the lower end. Okay. Let me illustrate. Please remember this. If you have a notebook with you there, take note of the illustration of skewed distributions. Okay. So we have a normal curve. Again, ano ang values ng mean, median, and mode? Pare-pareho. So we call this symmetrical distribution. Symmetrical or normal or bell-shaped distribution. Okay. If it is not normal or if it is asymmetrical, then it could be this way, where the scores bounce around the high end. Ito baga ang low end ng number line, di ba? Low, high. If the scores bounce around the high end, then we say that it is negatively skewed. Please remember that. If the bunching of the scores is around the low end, then we say that this is positively skewed. In that case, as you can see, it is positively skewed. There are more frequencies of scores occurring at the lower end than at the high end. So positively, dito medyo nahihirapan ang mga bata to distinguish, or you to distinguish what is positively or negatively skewed. Okay. To give you maybe a clue, no? A short hint on how you're going to determine this, whether it's positive or negative. just remember your number line. Okay? Ang number line ay may positive, may negative. Diba? From 0, negative 1, 2, 3, etc. From 0, positive 1, etc. To the high end, to the low end. Now, what you're going to look for here is the tail end of the distribution. Where does the tail of the distribution point? In this case, the tail of the distribution point to the negative. Ulit po. The tail of the distribution point to the negative. That's why it is negatively skewed. In this case, the tail of the distribution point to the positive. Positive. Just remember your number line, okay? So this is positively skewed. Both of these are skewed. Both of these are not normal. Okay, remember, dito mas marami ang high scorers. Dito mas marami ang low scorers. Clear na po ba tayo? Alright. Gusto kong maalaala ninyo ito kasi palaging lumalabas po yan sa palagi po siyang lumalabas sa let. Okay. Now, let me go to the concept of variance, standard deviation, and quartile deviation. No, hindi ko yata aabutin. Anyway, next time I'm going to talk about it in passing. But I would like you to understand pretty well ano talaga ang ibig sabihin ng standard deviation. So, if you know the concept of standard deviation, then you can make the interpretation. Hindi yung nakikita, standard deviation is equal to 10. Oh, what about it? All right. Usually, research would report mean is equal to 50, and then opposite that, lalagay, SD is equal to 10. So, ano ang ibig sabihin niyan? Sige. Tanong ako, ha? Let me see. Let me give us a hypothetical example. I gave a test to 5 brilliant students. I gave a 10-item test to 5 brilliant students. They're all brilliant. So the scores, 10 out of 10. Does this score differ from the others? No. So if you get the mean of this, the mean is equal to 10, right? 50 divided by 5 is 10. Does this score differ from the 10? No, it doesn't. This one, all of these scores do not differ from the mean. So, ladies and gentlemen, there is no deviation of each of these scores from the mean. No deviation, no variation. Therefore, your SD there is equal to 0. So the nearer the value of the deviation or standard deviation or quartile deviation for that matter to 0, then the more homogeneous, walang variation, walang deviation around the mean. Is that clear enough? Ulit, standard deviation tells us how scattered the scores are around the mean. If the mean is 10, lahat yan ay 10. Walang score na nag-scatter away from 10. On the other hand, kung ang scores ay 0, 1, 5, 8, 4, ilan na? Okay, 5. Tingnan nyo, saan ang 1? Ilan ang deviation niya from 10? 9. So, nandoon ang 9. Ilan ang deviation niya from 10? 5. Nandito. Ilan ang deviation niya from 10? 4. Ilan ang deviation niya from 10? 3. 2. Okay. Look at the scatter of the scores. This is going to spell out, ang zero ay nandoon, napakalayo, no? This is going to spell out a huge standard deviation. Okay, let's illustrate this using concrete example. Ito ay 10, 10, 10, 10. Ang mean ay 10, walang deviation. SD is 0. Let's take another example. I gave a test to a different set of 5 students, and the scores are 8, 2, 5, 4, 1. Okay, what is the standard deviation of this? Let's add up and get the mean. 10, 20. What's the mean? Divided by 5, the mean is 4. Are you following? Let's get the deviation of each of this score from the mean. 4, negative 2, 1, 0, negative, deviation from 4, 3. Okay, are you following? Deviation from the mean, 4, 4. Deviation from the mean, negative 2. Deviation from the mean, 1. Deviation from the mean, 0. Deviation from the mean, negative 3. All right. Let's now square the deviation. The square of the deviation is 16. If you square negative and negative, then you get a positive. So, 4, 1, 0, 9. If you add up the square deviation, you get 20, 21, 30. Right? 20, 21, 30. Are you following? And if you divide 30 by the number of cases, which is 5, you will have 6. This is now what we call the variance. Tingnan nyo, ang laki ng variance. Huh? Are you following? What did we do? We add up the squared of the deviations and divide that by the number of cases. All right, you got a variance of 6. We move one step further. If you get the square root of the variance, 6. What's the square root of 6? The square root of 6 is, let's try it, 6 square root. The square root of 6 is 2.45. Let's round it off. This is now what we call the standard deviation. All right? This is a lot different from the standard deviation that we got earlier, which is 0. Walang deviation. Ito ay malaki ang deviation in the amount of 2.45. Ano ang ibig sabihin ng 2.45? Okay. Ibig pong sabihin nito ay this set of scores, 8, 2, 5, 4, 1, deviates from the mean 2.45 on the average. So, may deviation po from the mean by 2.45 points. As against kanina na illustration ko, walang deviation na 0. So, mas malaki ang deviation, ulitin po natin, mas malaki ang deviation, mas malayo ang scatter ng scores. Mas maliit, nearer 0 ang deviation, mas homogeneous po. Mas homogeneous. Halos pare-pareho ang ability ng mga estudyante kung ang SD ay maliit. Maliwanag po. Okay. You will find that in the test. So far, meron pa sana akong i-discuss sa inyo, but I will leave that for later. Kasi ngayon po, i-explain ko sa inyo ang mangyayari. Ano po? Sa Saturday, no din tayo tao ang test.
Di ba 22?
Oh, 22. On the 22nd, you will receive 1, 2, 3 short quizzes or long test. I'll call that long test of 10 items each. Dapat, ito po ay masagot ninyo. Ah? You will receive this through your Google Classroom. So, pwede po ninyo itong sagutin at ipadala sa akin ang sagot lang. Ang sagot lang. Of course, ang test na yon ay nasa inyo, reviewhan na ninyo yon for your lab. Okay. Ngayon, ang Google Classroom is one set ng test yan, ano? Yung isang mahabang test na 40 items yon. Hindi 50 kasi yung 10 ay kukunin ko na po dito sa ibibigay ko sa inyong tatlo. Ang 40 item test na ito ay ibibigay sa inyo through Edmodo. Edmodo. Okay. I would like you to experience using this platform. Using this platform because when you teach, you might use this. Okay? Baka ngayon may mga nagtuturo na sa inyo, pwedeng gamitin ninyo ito sa inyong pagtuturo, sa inyong pagbibigay ng test habang tayo ay nasa pandemya pa. No? Wala pa tayong face-to-face instruction. So, you have to go through this experience of taking the test. However, because this is novel to you, this is, shall we say, something that is new, ano, then there might be a difference in your performance. Ano? Your performance might be affected by the novelty of this kind of taking the exam. So, titingnan ko po kung ano ang mangyayari. Kung kayo po ay mag-i-score ng medyo mababa, bibigyan ko po kayo ng pagkakataon. I'm going to adjust the kind of examination that you will get. Maybe there will be a take two. Let me just study what's going to happen. Because as I told you earlier, I don't want to give a low grade. I want to give you every chance to get a good grade. So, how do you earn your good grade? You will have to submit 3 exercises and 2 activities. The activities mabigat-bigat po ng konti, pero magagawa ninyo. And because mabigat-bigat ng konti, you're going to be given enough time. So, ibibigay nyo yan sa akin sa Setyembre na. Ano? Okay. Ito naman na exam na ito ay dapat sa Saturday. Kaya ito po na aking lecture ay ibibigay na sa inyo sa bukas, Friday. Can we do that? Yung ano, ito lang.
I have to edit it. Tapos upload ko pa sa
Okay. So, ibibigay yan sa inyo sa Saturday. Okay? Bibigay sa inyo at the time na magkakaroon tayo ng meeting.
yung video.
Video.
Exactly.
But the other one?
Yung file, pwede na.
Okay. Yung file na ito, yung aking lecture mismo, ay hindi yung video, ay maaari nang ibigay sa inyo. So, you can browse over this lecture already to answer the questions. Yung tatlo na tig-10 na items. Maliwanag po ba? No? Kung meron po kayo na itatanong sa akin, kasi bukas ibibigay na po itong lecture na ito, bukas na hindi pa natin klase, ibibigay na po yan sa inyo. Ngayon, pag-aaralan ninyo, gawin na po ninyo ang mga test na yon. At kung medyo nahirapan kayo, please tell me. No? I'm open to any suggestion from you para pakinabangan ninyo ang lecture na ito kasi mahalaga po ito. Ang tatalakayin ko sa inyo sa susunod, which is also very important, is the grading. Now, this is what I'm going to let you do now and until Friday, until tomorrow. No? This you can do. Please download Department Order, DepEd Order number 8 series of 2015. Hindi po pwede na wala kayo niyan kasi yan ang Biblia ng assessment sa K to 12. And I'm sure that most of you would like to teach in the K to 12. Ulit po, download ngayong gabi ay bukas, ano? What's this? Department DepEd Order number 8. Department Order number 8, series of 2015. Walang hindi pwedeng wala kayo noon. Otherwise, hindi po ninyo magagawa ang exercise number 3. Ulit ko po ha, hindi kumpleto ang tatlong exercise, hindi kumpleto ang dalawang activities, wala kayo ng tatlong test at sa isang malakihang test, wala kayo niyan ay hindi po kumpleto ang inyong grado. Mag-i-incomplete kayo sa akin. At hahanapin ninyo ako, hahabulin nyo ako kung saan nyo ako makukuha. Ha? O, sana maliwanag yan sa inyo, ha? O, sige, maraming salamat for now. I'll see you next meeting.